What is measuring strain and material failure? Imagine bending a paperclip and noticing how it stretches just a tiny bit before snapping. That tiny stretch is what scientists call strain, and measuring it helps us understand how materials behave under pressure. When a material is loaded with force, it deforms, either stretching, compressing, or twisting. Measuring strain tells us exactly how much deformation occurs relative to its original shape. This measurement is usually a very small change, often just a few millionths of the original length, so we use special units called microstrain units. 1 microstrain equals 1 part per million change in length. Understanding strain is essential because it helps predict when a material might fail or break. Engineers use this information to design safer bridges, airplanes, and even everyday objects. To measure strain, we need tools called strain gauges. These are tiny sensors made of thin wires or foil attached to the surface of the material. When the material deforms, the strain gauge also stretches or compresses, changing its electrical resistance. By measuring this change, we can calculate the amount of strain. There are other methods too, like Fiber Bragg grating sensors. These use optical fibers to measure strain over larger areas and can be connected to many sensors at once. Another advanced method is digital image correlation, which uses high-resolution cameras to track how the surface of a material moves and deforms across a broad area. This technique is especially useful for complex shapes or large structures. Measuring strain is a key part of understanding how materials fail or break down. It helps engineers see early signs of damage and make improvements to prevent accidents. For example, in aerospace, measuring strain on airplane wings can reveal stress points that might cause cracks. In civil engineering, it helps monitor bridges and buildings for signs of wear. By keeping track of how materials deform under load, we can keep structures safe and reliable for a long time. In essence, measuring strain is like taking the pulse of a material. It tells us how much it stretches or compresses before giving way. This knowledge helps us design better, stronger, and safer products and structures in our everyday lives.